Greetings everyone, this is Mr. Mullen. In this podcast, I'm going to show you how to do unit conversions using a process called dimensional analysis. And let me tell you, you will use this skill again and again in chemistry. So let's go ahead and get started. This idea of dimensional analysis. Remember in third grade those annoying story problems where you had to convert from 4 quarts to gallons, and you realized that you either had to multiply or divide by 4, and sometimes you got it right. You had to ask yourself if the answer made sense. I mean, are quarts bigger, are gallons bigger? And you were able to figure out an answer. But I want to show you a way that you can use conversion factors to convert from one unit to another effortlessly. In order to do this, we're going to take the advice of the wise sage Yoda. And Yoda would say, "Your guide let the units be." What this means is that units are going to guide how you solve these problems. Let's look at a problem. Let's say on Tatooine, where weight is measured not in pounds but in kilograms, Yoda goes there and wants to find out what is his weight in kilograms. He knows that he weighs 112 pounds. But on Tatooine, they don't use pounds as the unit of weight, they use kilograms. So what Yoda did is he would go and he would look on a chart very much like the one you have, and he would find a equivalent statement or a statement of equality for pounds and kilograms. How are they related to each other? And so this is where we need, when we look at this problem, this is where we're going to need an equivalent statement from some kind of chart. So, what are conversion factors? What are equivalent statements? So a good example of equivalent statement is one from your conversion factors sheet. A mile is equal to 5,280 feet. Okay, so these are both units of length. And it turns out that if I take the distance between point A and point B, that's going to be 1 mile. And if I measure it using a mile stick, if we had one, it would take 1 mile. But let's say I don't have a mile stick, but I do have a ruler. And I stack rulers end to end. And every ruler is a foot. If I were to go end to end all the way from point A to point B, I could still measure that length, but it would be 5,280 of those little tiny feet. So when I look at this equivalent statement, we say it's an equivalent statement because 1 mile and 5,280 feet are the exact same quantity of distance. However, feet is a much smaller unit, so it takes a lot more of them to fill out that space. Both sides represent the same amount of stuff. So I'm going to show you how we can use an equivalent statement to go from one unit of measure to another. What we can do is we can turn in the equivalent statement into a ratio. And in ratio form, because we said that there's the same amount of stuff on each side of that equation, whenever I divide something by itself, I get 1. A great example is a mile divided by a mile. The 1's cancel, the miles cancel, 1 divided by 1 is 1. So, if we're talking about the same amount of stuff, if I put in ratio form that 1 mile is 5,280 feet, or that 5,280 feet is 1 mile, and I divide those, when I divide something by itself, it always equals 1. So what we can do is we can use this ratio form of an equivalent statement to convert from one unit to another. And mathematically, when we multiply any number by 1, it's always the same value afterwards. So when we multiply something by a conversion factor, it doesn't actually change the value of what we measured. Before I leave this, I want to ask a question. And the question is, do the numbers have to go with the units? So when I look at something like this, 5,280 feet, is it okay if I write that in 1 feet is equal to 5,280 miles? Is that appropriate? And if I look at that ratio and I realize that it doesn't make sense, then I cannot write it that way. So I would ask myself, in 5,280 miles, which is a really big unit, is there only 1 foot, which is a really small unit? And you should be shaking your head, well, no, that doesn't make sense at all. So this we cannot do. Do the numbers have to go with the units? Absolutely. If the numbers don't go with the units, from the equivalent statement, then you've made a statement that isn't really equal. It's not really true. And you always want to double check as you're writing these down which way you're writing it so that they do in fact make sense. So let's go back to our example. So we want to figure out what is Yoda's weight in kilograms. A way that we could write this out is his weight, 112 pounds, is equal to question mark how many kilograms. So we're going to do a conversion factor, and I'm going to make it kind of easy for you in the beginning. We're going to take a starting quantity and unit, and we're going to go ahead and take our starting quantity, and I'm going to write 112 pounds times, and I'm going to put a little conversion factor bubble. Okay, we're going to need to fill this out. Now, as I'm looking, I want to convert from pounds to kilograms. What I'm going to need to do is I'm going to need to go to a conversion factor chart and find a relationship between kilograms and pounds. So what I would do right now is I would pause this video, pull out that sheet, and try to find one. As you're looking through that sheet, you're going to find out that on that sheet there's a conversion factor that says 0.4536 kilograms is equal to 1 pound. This is an equivalent statement from that conversion sheet, and we're going to use that. We're going to put it in the ratio form so that we can convert from one unit to the other. So I look at that chart value, and we're going to put it into a multiplication problem in a way that the units that you want out of the problem are going to go on the bottom so they can cancel out, and we're going to leave the units we want left on top. So letting the units guide us, like Yoda would say, we want to get rid of pounds, so I'm going to put it in the bottom. And we want to get to kilograms, so I'm going to put it on the top. Once I realize how I'm going to write my units to get to kilograms and be left with pounds, you could even go further and say, well, whatever numbers I put in here, I know that pounds will cancel and kilogram will be left standing. So now we need to do a little math work. Remember, I'm just multiplying this by 1. Okay, just multiplying by 1, so it's okay that we do this. So I look at my conversion factor chart. And I have these equivalent statement here. So now we need to put it into this expression. So 1 pound, I have to put the 1 next to pound, otherwise it wouldn't make sense, is equal to 0.4536 kilograms, 0.4536 kilograms. So what I can do now is I can take out my calculator and I can multiply all the numbers on the top, 112 times 0.4536, divide every time I see a number in the denominator, divided by 1, and we're going to multiply that out, and we should get that it's equal to 50.8 kilograms. Now, I'd like you to take a special notice here. Sig Figs. I start with 3. Yoda knows his weight in pounds, 3 Sig Figs. So 3 Sig Figs. And I look at this equivalent statement here, and I want you to assume that all equivalent statements are chart values. So that means that their significant figures do not count in operations. They have their exact numbers. I want you to treat them like exact numbers. So we're not going to count that there's 4 Sig Figs there. We're going to say it has unlimited Sig Figs. So I'm only going to look at what I measured, and I'm going to round to 3 Sig Figs in my final answer. And when I have my units cancel, we're left with kilograms on top. We're able to get a final answer. The last step is to check to see that it makes sense. And so I'm going to look back, and I look at my conversion factor, and I notice that a kilogram is smaller than a pound. So if I have 112 pounds, because kilograms are smaller than pounds, I should have less kilograms than pounds. When I convert that to kilograms, because kilograms are smaller, I should have less of them than I should have pounds. So this answer does make sense. The other thing I would do at the very end to check that it makes sense is also I would look at my units. Let's say I were to do this problem the exact same way, but I decided that I wanted to write my equivalent statement the other way. So I put a pound on top and 0.4536 kilograms on the bottom. If we were to do this, and the units were our guide, notice that the unit of pound on top does not cancel with kilograms on the bottom. And if I have pounds times pounds, I'd actually get some weird unit like pounds squared over kilograms didn't cancel. And pounds squared over kilograms is not what I want, which is a unit of kilograms. We're back at the beginning. I would know that I would have to write this in a different way because my units just wouldn't make sense. So, in summary, all you have to do is let the units be your guide, and as Yoda would say, your guide let the units be. This has been a short podcast to show you how to do conversion factor problems, and I hope that this was helpful.